Hello viewers, now I am going to discuss about Corey-Chaykovsky reaction. Usually the reaction depends on sulfur ylides. If you look at the scheme, the question was asked in GATE 2021. From the same starting material, they got two different products. One is epoxide and another one is cyclopropane. Depends on what kind of sulfur halide we are using for the reaction, the particular the product we are going to get it. Okay, let us move on to the main topic. So I'm going to discuss about first ylides. What is ylide? The species with positive and negative charges on adjacent atoms called ylide. Now just I want to compare between Corey-Chaykovsky reaction and wittig olefination. I think most of the people they are familiar with wittig reaction because in wittig reaction we use phosphorus ylides. Whereas in Corey-Chaykovsky reaction we are going to use sulfur ylides. That is the main difference. But in wittig reaction, suppose if you take aldehydes or ketones, in this case we are going to take cyclohexanol. Through wittig reaction, we will end up with a corresponding olefin. But in the case of Corey-Chaykovsky reaction from cyclohexanol, we will get the corresponding epoxide. That is the main difference. Actually, these sulfur ylides are the mainly two types. One is trimethyl sulfonium iodide. Another one is trimethyl sulfoxonium iodide. How we are going to generate these ylides? I will discuss now. For generating trimethyl sulfonium ylides or trimethyl sulfoxonium ylides, these ylides are highly unstable. We need to generate in situ. If you take dimethyl sulfide and treat with methyl iodide, we will get the corresponding trimethyl sulfonium salt, which is very stable. Even commercially we can get it. The salt, if you treat with base, here we use sodium hydrate, but even if you use potassium tertiary butoxide, which is a strong base like a sodium hydrate, then we will get trimethyl sulfonium halide, here S plus and CH2 minus. And this is quite unstable. When we are generating, we need to maintain inert condition. Similar way, trimethyl sulfoxonium halide can be generated, but here we are going to take dimethyl sulfoxide. Then again we have to treat with methyl iodide. This is also salt and more stable. This is also commercially available. If you treat with base, we will end up with the corresponding trimethyl sulfoxonium halide. Just I want to discuss the advantage if you use Corey-Chaykovsky condition. Let us see what are the advantages are there. In first example, I am going to discuss about beta blocker drugs. Everyone know that beta blocker drugs we use for reducing hypertension. Here, the amino alcohol is one of the beta blocker drugs. For synthesizing, here we took the substituted benzaldehyde. Through wittig olefination, the corresponding in step 1, we can get the corresponding styrene. But if you treat with mCPBA, then we'll end up with the corresponding epoxide. And this reaction is called privilegium olefin epoxidation. Then we can treat with the corresponding amines. The epoxide can be opened by the which amine we are going to take. But here for getting amino alcohol, we need to do 3 steps. But if you replace with Corey-Chaykovsky condition, we can do it in 2 steps. That is the one added advantage. The second example, this is one of the intermediates in the strychnine. Strychnine is one alkaloid. It can be used in the pesticides. The intermediate, the product epoxide we need to introduce. The starting material is corresponding aldehyde. Like the first example, as we discussed, if you do wittig reaction, then we'll get the corresponding olefin, then mCPBA. Do you think the here, if you treat with mCPBA, can we get it in the less substituted epoxide? But it never takes place. Here, there is another problem is there. Whenever we are using peroxide like a mCPBA, metachloroperoxybenzoic acid, it will go to the highly substituted olefin. Here, whatever the highlighted with the red color, the epoxide, it will take place in highly substituted olefin rather than the less substituted olefin. And one more drawback if you use mCPBA, which is the amine also it can go for the oxidation, then it will end up with the corresponding N oxide. And one more disadvantage if by using mCPBA, which is whenever we are doing in the bulk scale, since it is a peroxide, it may cause explosion. But now if you replace with the Corey-Chaykovsky condition, the specifically which is aldehyde, it will convert it into the corresponding oxygen. This is a very important. That's why the Corey-Chaykovsky reaction, it has a significant role in organic synthesis. Now I am going to discuss about the Corey-Chaykovsky reaction with the stabilized and unstabilized ylides. What is stabilized ylide? If conjugating group present on carbanion carbon atom of the ylide is called stabilized ylide. If you look at it here, the CH2 minus which is stabilized by the cyano, because cyano which has a triple bond, nothing but conjugated. In conjugated system it is present, that's why it is called stabilized ylide. But if you come to the trimethyl sulfonium ylide, which is an unstabilized ylide. There are three different cases are there. In the first case, the reaction of unsaturated carbonyl carbons with the stabilized and unstabilized ylides. Here I took one enone compound. After treatment with the stabilized ylide, now we got 1,4 addition product which is nothing but the cyclopropane. But whereas with the unstabilized ylide, we got the 1,2 addition, nothing but this is the oxyuride or epoxide. So the second case, which is in the absence of conjugated alkane, both the types of ylides gives epoxides. Now here instead of alpha beta unsaturated carbonyl, here I took both the carbonyl. If you use either of the ylide, like a stabilized or unstabilized, we'll end up with the corresponding epoxide. The third case, the same way, stabilized sulfoxonium ylides give the cyclopropane. Like a very beginning, I discussed there are two types of ylides are there. One is trimethyl sulfonium ylide and another one trimethyl sulfoxonium ylide. This trimethyl sulfoxonium also, which is a stabilized ylide. That's why we'll end up with the cyclopropane. Now my question is, why when we take stabilized ylides, we are going to get cyclopropane ring system. If you take unstabilized ylides, why we are going to get the 1,2 addition? Those are called oxides. Why? What mechanism it involved? So we'll discuss about mechanism now. The first case we will see the stabilized halide. So here I wrote one statement which is the reason behind why stabilized halides are 1,4 addition favorable whereas unstabilized halides are 1,2 addition favorable. So here I took stabilized halide because the CH2 minus stabilized by the corresponding ethyl acetate, not ethyl acetate, the ester. That's why this halide it comes under stabilized halide. When it is react to the carbonyl, the 1,2 addition which is very fast and reversible. Since the halide is a stable, which is favorable for the reversible, so it comes under kinetic product, nothing but less stable. But the second case, the stabilized halide, if it attacks 1,4 addition, which is slower but irreversible, then the compound we will end up with the cyclopropane, which is the more stable thermodynamic product. So we will have a look other case which is unstabilized halides. In this case, the CH2 minus it attacks the carbonyl of enone, which is a fast but irreversible. The first case, whenever we used the stabilized halides, that is a reversible, that is not favorable for 1,2, but in this case, unstabilized halides case, the 1,2 is favorable. Then we will end up with the corresponding epoxide, whereas 1,4 is pretty slow. That's why the finally, when we use stabilized halides, we will end up with the cyclopropane, but when we used unstabilized halides, we'll end up with the corresponding epoxide, that to 1,2 addition. So thank you everyone.